Since philosopher Nick Bostrom proposed in the Philosophical Quarterly that our universe might be a simulation, there has been a great deal of public speculation and debate about the nature of reality. Elon Musk has also suggested that it's statistically likely that our world is just an elaborate computer simulation. Recent studies have expanded on Bostrom's idea, suggesting there's a 50-50 chance that we live in a simulated reality. This hypothesis has received considerable attention due to endorsements from notable figures like Neil deGrasse Tyson. Physicist Frank Wilczek contends that the immense complexity of the universe argues against it being a simulation, pointing out that such complexity would demand vast resources, making it inefficient. Sabine Hossenfelder, a physicist, argues that since the simulation hypothesis cannot be tested or disproven, it does not qualify as a scientific theory. These discussions have overlooked a critical aspect of scientific investigation: empirical assessment and data collection. To explore whether we might live in a simulation, we should consider how our current computers operate, running various simulations for less complex intelligence or algorithms. Imagine these as the non-player characters in video games. Any algorithm functioning on a computer serves as a model for this thought experiment. The sophistication or consciousness of this intelligence isn't the focus. Rather, the key lies in the evidence left by all computer programs, regardless of their complexity or speed. All computing hardware leaves a trace within the simulations it runs CPU speed. If we imagine ourselves as software on a computer, this speed would be the only constant artifact of the hardware that supports us. All other laws we experience would be those of the simulation or software. In games like Grand Theft Auto or Starfield, these laws would be the game's rules. Nonetheless, everything we do would be bound by the processor speed, regardless of the game's rules. In computing systems, CPU speed affects operations at the most fundamental level. A 64-bit processor subtracts large numbers as quickly as it subtracts smaller numbers like 1 and 2, assuming all numbers are the same type. In the simulated world, 2 million is vastly larger than 1, but in the physical realm of the CPU, the size difference is irrelevant. Both operations take the same time, highlighting the contrast between the simulated and physical worlds. In programmed mathematics, the speed of operations per second reflects an underlying artifact of the physical computing machinery. This artifact appears as an additional component in any operation, unaffected by the magnitude of the variables within the simulated world. The maximum container size for variables in a given system determines this component. For example, in an 8-bit computer, this size would be 256. The hardware component remains irrelevant until it presents itself as the maximum container size. Observers within the simulation can't measure the processor speed except when it appears as an upper limit. If we are in a simulation, our universe should exhibit a similar artifact. Here are some properties to identify this artifact. It is an additional component of every operation, unaffected by the magnitude of the variables. It appears as an upper limit within the simulated world. It cannot be explained by the simulated universe's laws and must be accepted as a given. Its effect is absolute, with no exceptions. This artifact in our universe is the speed of light. Space in our universe is similar to numbers in a computer simulation. Matter moving through space can be seen as operations on the variable space. If matter moves at 2,500 miles per second, then 2,500 miles of space are transformed every second. If a hardware simulation runs our universe, the maximum limit on the container size for space operations would appear as a maximum speed in our universe, the speed of light. This observation implies that if we inhabit a simulation, space is an abstract construct coded into the system rather than a physical reality. Directions and distances are just symbolic representations. The speed at which anything moves through space reflects the degree of causal influence on the space variable. This influence cannot surpass approximately 186,000 miles per second, suggesting that the speed of light is a hardware artifact of our simulated existence. But there is another indication that we might live in a simulation, one that lies within our own experience. Consider characters in role-playing games like Starfield or Grand Theft Auto. The algorithms representing the characters and the game environment are interconnected. Even if they are separate, characters don't need a visual perspective to interact with their environment. The visual projection we see is for our benefit, a subjective interface for experiencing the game. Similarly, movies show us scenes from a character's perspective for our enjoyment. The integrated experience exists entirely for us, the observers. This leads to a profound question. Why do we have consciousness? The simplest explanation, once we accept the simulation hypothesis, is that consciousness is an integrated subjective interface between ourselves and the universe. Its primary function is to provide an experience. This experience is too costly and restrictive to have evolved solely for evolutionary advantage. It likely exists to serve as an experience for someone else. Natural laws don't predict the emergence of consciousness, and it doesn't seem to offer significant evolutionary advantages. Thus, there are two explanations. Either unknown evolutionary forces select for consciousness, or consciousness is a product we create, serving someone else. While we don't know who benefits from this experience, we know it exists and is a product we generate. One criticism is that, unlike game characters, we experience sense data, or qualia, ourselves. If this product is for someone else, why do we experience it? The answer lies in the shared experience between the player and the character. In virtual reality, for instance, players feel some of the character's sensations, like gravity on a roller coaster. Similarly, as we experience the world and generate qualia, we might be experiencing a small part of the qualia ourselves, while a more information-rich version is projected to another mind. In conclusion, the simplest explanation for consciousness is that it is an experience created by our bodies, but not for us. We are qualia-generating machines, like characters in Grand Theft Auto, producing integrated audiovisual outputs for the benefit of someone experiencing our lives through us. Thank you for watching. If you enjoyed this content, please like, comment, subscribe, and share.